The race to outdo each other in the artificial intelligence space has reached a new level as Meta announced a new language model based on artificial intelligence. The language model called
Imagine you know how to worldly picturize something but don't know how to make that into an actual picture. But what if I say Facebook's parent company Meta is here to help you with this, with a chameleon model technology? This is the first model of its kind. Meta AI introduced Chameleon, a new multimodal model that combines text and image production, using formulas and techniques modified from text-language models to deliver remarkable results with unparalleled computational efficiency. Chameleon is the first multimodal model to be trained with a formula adapted from text-language models, including a large-scale recovery reinforcement pre-training phase and a fine-tuning SFT phase, has second multitasking supervision. Meta said in a blog post. Given the capabilities of Chameleon, the company says the imaging tools can produce more consistent images that better follow input prompts. According to Meta, Chameleon requires only 5 times as much computing power and a smaller training dataset than previous transformer-based methods. Compared to the most widely used imaging benchmark, MS COCO without clamps, the Chameleon achieved a fresh at inception distance FID score of 4.88, setting a new state-of-the-art in text generation. To image and pass Google's text to an image, picture model, particular applications in the metaverse. So Meta is trying to explore the limits of multimodal language models and releasing more models in the future. The internet has made it possible to collect billions of pairs, alt text images from HTML pages. Schumann et al. 2022. Enabling recent breakthroughs in the text-to-shape model image that is T21. However, this successful replication for video is limited because similarly sized datasets, like text and video, cannot be easily collected. It makes no sense to train text-to-video T2V models from scratch when models capable of generating images already exist. Inspired by these dynamics, Meta came up with Make a Video. Here, Make a Video leverages T2I models to learn correspondences between text and the visual world, and uses unsupervised learning on unlabeled, unpaired video data to learn actual movement. Together, Make a Video creates videos from text without leveraging text-video matching data. This model generates text into images at industry-leading speeds while using 5 times less computing power than previous transformer-based techniques. It maintains low training costs and high interference efficiency. What can Chameleon do? Chameleon has both the power and adaptability characteristic of autoregressive models and outstanding efficiency and cost-effectiveness in the learning and inference stages. This important step overcomes the limitations of previous templates, which were limited to performing exclusive text or image generation tasks. Chameleon's architecture uses a decoder-only transformer similar to well-established text models. This is what makes this model special. What sets the Chameleon apart, however, is its ability to capture and export text and images. This allows Chameleon to handle tasks like quick queries and model building. Due to their superior performance and low computational cost, diffusion models have recently taken over imaging efforts, says Meta, according to Meta's research on self-regressive multimodal models. Increasingly complex generalized models are trained on millions of image samples to learn the relationship between images and text, but they can also reflect biases found in the training data. While AI-generated imagery has become increasingly familiar through popular tools like Stable Diffusion, DALL-E, and Midjourney, Meta AI's approach to building Chameleon and the performance it promises to deliver is a significant step forward. Meta gives Make a Video a way of directly translating the recent advances in text-to-image (T2I) to text-to-video (T2V) creation. Their intuition is pretty understandable. Explore the world and how it is depicted from concatenated textual image data and discover how it evolved from unsupervised video footage. Make a Video has 3 advantages. Number 1 is it speeds up T2V model training. It doesn't need to learn multimodal and visual representations from scratch. And it doesn't require concatenated text-video data. And number 3 is generated videos inherit today's imaging model's vastness, variety of aesthetic expression, imagination, etc. Meta is designing a simple yet effective way to build on T2I models with new and efficient spacetime modules. First, they decompose the entire temporal U-net and attention sensors and estimate them in space and time. Second, design a spacetime phenomenon to generate high-resolution frame-rate video with a video decoder, interpolation model, and 2 super-resolution models that can support various applications beyond T2V. So in all aspects, we can say spatial and temporal resolution, text fidelity, and quality. Make a Video establishes a new state-of-the-art in text-to-video creation, defined by qualitative and quantitative measurements. So to take advantage of the earlier mentioned 3 aspects, Chameleon Make a Video consists of 3 main components. Number 1, a base T2I model trained on text-image pairs. And number 2, spatiotemporal convolution and attention layers that extend the network's building blocks to the temporal dimension. And number 3, spatiotemporal networks that consist of both spatiotemporal layers as well as another crucial element needed for T2V generation. How did Meta train the model? The various Make a Video components described above are controlled independently. The only element that receives text as input is mentioned previously. They train it on concatenated text-image data and don't adjust it on video. The decoder, a priori, and 2 super-resolved components were first trained on the image, no aligned text. After training on the images, and initialize new temporal layers and refine them on the unlabeled video data. 16 frames sampled from the original video with random FPS between 1 and 30. Meta used the beta function for sampling, and when training, the decoder starts with a high FPS range, less motion, then switches to a lower FPS range, more motion. The masking interpolation component is refined from the time decoder. What are the limitations of Chameleon and how Meta tackles them? Of course, the text describing the image does not explain all the phenomena observed in the video. That said, actions and events can often be inferred from still images. Example, a woman drinking coffee or a soccer elephant, as implemented in image-based action recognition systems. Furthermore, even without written descriptions, unsupervised videos are sufficient to learn how different entities in the world move and interact. Example, wave motion at the beach or trunk. As a result, a model that sees only text describing images is surprisingly effective in generating short videos, as demonstrated by our time diffusion-based method. Meta trains super-resolution spatial and frame interpolation models to improve image quality. This increases the resolution of the generated video and allows for a higher controllable frame rate. They present Make a Video, an effective method to extend the diffusion-based T2I model to T2V through the spatially factored diffusion model. They leverage common text-image preferences to avoid the need for concatenated text-video data, allowing us to scale to larger amounts of video data. As a next step, they are planning to address some technical limitations. As we discussed earlier, Meta's approach cannot understand the connection between text and phenomena that can only be inferred in the video. How to integrate them, for example, creating a video of a person waving from left to right or right to left, and creating a longer video with more scenes and events, illustrating stories in more detail will be covered. For future work, they said. As with all large-scale models trained on data from the web, Meta models learned from and likely exaggerated social biases, including harmful biases. The T2I generation model was trained on data that removed NSFW content and malicious words. They are making all of the data, images and videos publicly available, adding a layer of transparency to the models and allowing the community to copy the work and research. You all can agree learning from the world around us is one of the greatest powers of human intelligence. Just as we quickly learn to recognize people, places, things, and actions through observation, systems are more creative and useful if they mimic human learning, right? So, understanding global dynamics from videos of varying magnitude using unsupervised learning helps researchers break free from reliance on labeled data. The Meta's new model shows how effectively paired labeled images with unlabeled video sequences can achieve this. So, what's your thought on Chameleon? Do comment.